0, it should be -1. So from -1 to 3, there is only one impulse lying between that, which is lying at n equals to 0. And the magnitude of that impulse is nothing but this is 1. So this AK find out to be 1 by 4 for all values of K. And if you take the magnitude of AK, you can plot your AK like this. AK is 1 by 4. So the Fourier series coefficient for this series is 1 by 4. So your answer becomes this 1 K indexing of n or indexing of 4, 1 by 4 e to the power j k pi by 2n and so on. So there are only uh, 4 impulses which is capable of representing of your original signals. Now we have another numerical x of n is cos square pi by 8n. So cos square pi by 8n, you can put it like this. E to the power j pi by 8n plus e to the power minus j pi by 8n by 2, and you can take the square of that. So you will have these many number of expansions, 1 by 4 e to the power j pi by 4n plus 1 by 4 e to the power minus j pi by 4n plus 1 by 2. And since we already know that you can compare this equation from the original mathematical equation, which is this ak e to the power minus j. And when you compare this by knowing the fact that capital N is 8 and your omega becomes pi by 2 pi by 8, that is pi by 4. Now if you compare this, so you will have a naught is 1 by 2, a1 is 1 by 4, a minus 1 is 1 by 4 and so on. So these are the Fourier series coefficient which is capable of representing of your original signals. Now there were some few numericals that I already discussed, why the direct comparison of your original equations, you can have the different Fourier series coefficient. Now similar to the continuous time Fourier series, here we also have the properties of the discrete time Fourier series. So let's say we have two signals xn and yn of period capital N, and their fundamental frequencies is capital omega, which is 2 pi by n. Now the number of property that it will follow is most of the properties are similar to the previous case, only few properties are different. So property number 1 is linearity property. So if capital A xn plus capital V by n is an composite signal, then the Fourier series coefficient will again be multiplied by is capital A and capital V. So this is capital A AK plus capital V BK, where AK and BK are the Fourier series coefficient of xn and yn. Now we have a time shifting property that if your original signal is being shifted by n naught, so Fourier series coefficient will be multiplied by a factor which is e to the power minus jk capital omega smaller. We have a frequency shifting property. If your original signal is multiplied by a factor of e to the power j capital M 2 pi by n, then the Fourier series coefficient is your ak minus m. Now, if your signal is being conjugated or the complex conjugate, let's say xn is having Fourier series coefficient ak, then conjugate of x of n is having Fourier series coefficient conjugate of a of minus k. Time reversal, if you replace x with minus n, so your ak becomes a minus k. Time scaling is something like if x of m of n, which is given as x n by m. If n is a multiple of m, remind these things, we are dealing with the discrete time of signals. So n must be a multiple of m. Only then this is possible that we can do the scaling of a discrete time signal.
Sir, what is this m? Come again, please.
This small m indicates the scaling factor. Something like if I am writing x at, So A is the scaling factor. So here in case of discrete, I am writing x m of n, which is actually x of n by m. So the scaling factor is m. But remind one thing, this scaling factor must be the n should be a multiple of m. Otherwise, the scaling cannot be done, because every time you require that n by m must be a integer, because we are dealing with the discrete time signals. And if it is not a multiple of m, so we have 0 over there. Under this case, if a signal is being scaled by this much amount, then the Fourier series coefficient will also be scaled by a factor of 1 by m. So original signal x of n with Fourier series coefficient ak. Now if it is being scaled by a factor of 1 by m, then your original Fourier series coefficient will be shifted by or multiplied by 1 by m, something like this. Now similar to the continuous time Fourier series, we have a periodic convolution. If you convolve these two signals xn and yn, so we have, let's say, xr y of n minus r summation of r indexing of n, then your Fourier series coefficient becomes capital N, ak and bk. This property you will also use in LTI system when you apply x of n, h of